All right, this is on subtracting rational expressions. So we've spent some time already working with adding rational expressions. So we want to first find out if the denominators are the same, which in these two expressions they are. So we have an x plus 2 and an x plus 2. They are the same. So what we do is we go ahead and combine the numerators. So 2x minus 1 minus 4x plus 4. And then we keep that denominator, x squared plus 2. Now we're going to go ahead and simplify the numerator. So we are going to drop the first parenthesis, so 2x minus 1. And then we're going to distribute that negative 1 into the second binomial. So we now have a minus 4x and a minus 4. The denominator still stays the same. Now we're going to go ahead and combine like terms. So we have a 2x and a minus 4x gives you negative 2x. And then we have a negative 1 and a negative 4 makes that a negative 5. And then all over x squared plus 2. And then we want to see what would make that denominator undefined. So x squared plus 2 cannot be 0. So then we solve this for x. So we subtract 2 from both sides. And then we square root both sides. And what we get is imaginary numbers. So there are no domain restrictions. We do not have to worry about any values for x, which makes it undefined. All right, here's our second example. Again, the denominators are the same, so we can go ahead and combine the numerators. So 3x squared minus 5 minus 2x squared minus 3x minus 2 all over our 3x minus 1. Now we're going to simplify. So we have to drop the first parentheses. Now the second one, we have to change all of the signs. We're distributing through a negative 1. So that becomes a negative 2x squared, a positive 3x, and a positive 2, all over 3x minus 1. Now we look for like terms. So 3x squared minus 2x squared is x squared. Then we have plus 3x. Then we have minus 5 and plus 2 gives us minus 3. And then all over 3x minus 1. Then we look for our domain restrictions. We look at the denominator, what would make that undefined. So we say 3x minus 1 cannot equal 0. We solve it. So we add 1 to both sides. And then we divide both sides by 3. So we say x cannot be 1/3. All right, this example, notice the denominators are not the same. So we first factor. The denominator as the difference of 2 squared, so x plus 3 and x minus 3. And then the second rational expression is just x plus 3. So then we look for the least common denominator. So they both have an x plus 3, but then this fraction does not have an x minus 3. So the least common denominator will be x plus 3 and x minus 3. So what we have to do is we have to increase this second fraction by what we're missing. So we didn't need to multiply by a x minus 3 and an x minus 3. So now we're going to go ahead and multiply across. So I'm going to go ahead and create parentheses here. Multiply across, subtract. So this will be our numerator. So 2x squared minus 3, and then minus x plus 5 times x minus 3 all over x plus 3, x minus 3. Now we do have some multiplying to do. We have to FOIL this out. So x minus 3, positive 5x minus 3. So we get, I'm just going to put that up here, x squared. I'm just running out of space, so I probably would write it down below, but we don't have enough space on this slide. So x squared, and then outside, minus 3x, inside, positive 5x, and then minus 15. So there's the FOIL of these two binomials. So now we can go ahead and simplify. So 2x squared minus 30. And now we have to distribute this negative into all of these terms. We have to change all those signs. So that becomes a minus x squared, a positive 3x, a negative 5x, and then a positive 15. And then all over x plus 3, x minus 3. Now we look for like terms. So 2x squared minus 1x squared is x squared. Then we have positive 3x minus 5x is negative 2x. And then negative 30 and positive 15 make that a negative 15. All over x plus 3, x minus 3. Again, for my class, you did not have to distribute out that x plus 3 and x minus 3. And then we look for our domain restrictions. What would x not be? 0 in the denominator. We do not want it to be positive 3 and negative 3. All right. This example, just like the last one, does not have the same denominator. So we first factor. So we're going to use the difference of two squares. So we have x plus 8 times x minus 8. And then the second fraction just stays as it is. So now we look for the LCD. So this first denominator has an x plus 8 and an x minus 8. The second one just has the x plus 8. So what we're missing from the LCD in the second fraction is that x minus 8. So we have an x plus 8 and an x minus 8 is the LCD. So what we do is we multiply the numerator and the denominator by what we're missing from the LCD. Now our fractions are alike. So we can go ahead and combine the numerator. So we have 2x squared plus 64 minus x minus 4, x minus 8, all over our LCD. Now we have to distribute, so we have to FOIL those two binomials. So we get x squared minus 8x minus 4x plus 32. And then everything else stays the same. All right. Now we have to distribute that negative into all of the terms. So essentially it's going to take this as a negative, a positive, and a negative. Now we look for like terms. 2x squared and negative x squared become x squared. Positive 8x and positive 4x is positive 12x. Positive 64 and negative 32 makes that a positive 32 all over x plus 8 times the quantity x minus 8. Our LCD, we did not want x to be 8 or negative 8.